Hi, in today's lecture we're going to talk about some of the issues around sustainable livestock production. We are at a crucial time for livestock agriculture where we need to maximise production and minimise pollution. But great care must be taken when assessing systems due to the complexity of the algorithm required for sustainable intensification. Justification of intense production solely on the grounds of carbon can raise serious ethical and product quality issues. Clearly, there is a role for livestock to utilise feed that humans cannot consume to produce high-value protein that they can. However, intensification has its associated risks such as water and air pollution, soil erosion and reduced fertility. Intensification of livestock to be delivered sustainably must work across and within sectors. It must look to maximise efficiencies in feed systems and in nutrient flows. It must look to reduce waste and recognise the importance of animal welfare. So the first area I wish to talk about today is competition with human edible food and waste. From a ruminant standpoint, ruminants will always have a higher carbon cost than monogastrics. They produce methane as part of fibre digestion, so will significantly produce more carbon per unit of product than pigs and poultry. Also, if you look at feed conversion ratios, so the amount of feed you need to give the animal to produce a kilogram of product, ruminants also stack up badly in this balance because typically the feeds they consume are less energy dense. However, the conversion and the ratio we need to look at is actually feed conversion based on human edible feed. So the amount of human edible feed being fed to that animal to produce a kilogram of human edible livestock products. And when you do this analysis, the benefit of ruminants comes to the fore. Ruminants' ability to utilise fibre and non-protein nitrogen is critical for sustainable food production. Whereas monogastrics rely on high-quality feedstuffs, which puts them in direct competition with humans. Every year, 1 billion tonnes of wheat, barley, oats, rye, a third of the world's cereal grains are fed to livestock. This is enough to feed 3.5 billion people. As well as cereals, there is huge demand for protein. The impact that soybean production has had on South America and global trade is immense. How can we feed livestock protein without relying on imports of soybean? We need to look at homegrown alternatives, protein sources which can be grown in the country of origin, such as lupins, peas and beans. But this competes for human edible protein. So what other alternatives are there? Well, we can look at green waste. So this is waste coming from food production which is not edible for humans. We can look at high protein byproducts. Reassess the role of meat and bone meal in omnivorous diets, so animals which can consume meat and protein from animal products, such as pigs and poultry. And also looking at processed animal protein and how it can be recycled into the diets of monogastric animals, who are omnivores after all. Also the vital and exciting role of insects in animals' diets. Insects can convert waste into high quality protein, which can be fed either directly to humans or to livestock. And also the potential of reusing swill in poultry and pig diets. The third area is tackling waste. We talk about needing more food, but we need to waste less. Waste comes from two areas when we talk about livestock production. First of all, waste from disease and illness of livestock. Disease kills young animals before they reach slaughter weight, before they're reproductive, before they lactate, and it will also significantly reduce production goals. This negates huge potential for genetic development and is a significant waste from the system. Solutions are there, and we need to expand these in the developing world by improving hygiene and quarantine and look at preventative medicine. The second area is food waste itself. and 1.3 billion tonnes of food is wasted per year. For livestock, this equates to about 50 million tonnes of meat and 120 million tonnes of dairy. And where this waste occurs in the different parts of the world is split between the developing world, where waste is predominantly at the production level, and the developed world, where waste is predominantly at the consumer level. Parts of the solutions for sustainable livestock systems are about integration and integration of farming systems. Mixed farming is common worldwide. Typically, when resources are cheap, this leads to specialisation. But when resources are limited, then this leads to mixed farming systems, which can be more efficient but often yield less of a single product. So the advantages of mixed systems are they're reducing risk, spreading labour, and reutilising resources, including improved nutrient capture. Disadvantages of mixed systems are reduced economy of scale and knowledge of different enterprises. Farmers have to be skilled in different systems, and that can often be a challenge to start with. Types and examples of integrated systems are on-farm versus between-farm mixing. So crops and livestock on the same farm, or the transfer of nutrients, for example, of dung from livestock farms to arable farms. So mixing between different enterprises. We can have mixing with crops and animal systems, for example, in arable mixed cropping systems, or for livestock, different grazing systems. So you could have sheep and cattle grazing, so you're maximising your sward in different ways. There are diversified versus integrated farming systems. So independent enterprises to spread risk versus an integrated system to recycle resources and nutrients. For example, a grain, legume, grazing system. The critical point for integrated farming systems is that the yield of the total enterprise is more important than the yield from a single element of that enterprise. So even though you might have a lower milk production than a solely milk enterprise, your total enterprise for, say, milk and beef would be higher. And that's the importance of an integrated farming system. The third area is about matching the systems to the environment. Local breeds are adapted to their environment and often more resistant to climate, parasites and diseases. They are lower yielding, but are significantly lower input. Modern genomics can be used to improve selection and improve these native breeds as a starting point, because they are already evolved to be more resistant to disease and the climate. The FAO has indicated that 21% of the world's indigenous animal breeds are in danger of extinction. These animals hold the genes for the key for sustainable livestock production globally. If we lose these genes, we could lose the chance to have a sustainable livestock system. A perfect example is the virtual cow in India. She is the world's smallest cow. She is ideally suited to landless farmers. So the farmer can keep this animal in their family group, allow this animal to wander around, graze on scrap, return to the family home, and to be milked to provide milk for that family. Sustainability and trade-offs. To deliver sustainable farming systems, we need to deliver the three needs of sustainability. These are social, economic, and environmental. And if we think about a farming system, what a farmer needs to do is first of all provide societal need. So a high quality, nutritious food product, such as meat or milk. The second need is economic. A farm is a business. It needs to make a profit to such a level that would encourage young people to want to be part of agricultural systems and farming. The third need is environment. While the farmer is providing a product which society needs, which is delivering a profit for the business, it cannot destroy the environment that will affect future generations' ability to provide products and economic returns for future generations. That is the cusp of sustainable farming systems, those three needs. But how do we deliver those three needs? We can look at this from two examples. The first one I want to look at is in beef systems. A beef system can have many different metrics of assessment based around these three needs. So we have animal performance in terms of live weight gain, carrying capacity, the amount of animals on the land, nutrient provision, so the amount of nutrients that your product will provide for human nutrition. Other assessments need to include environmental impacts, so nutrient loss to water and greenhouse gas production. For livestock, it's critical to include animal health metrics and animal welfare, the impact of your farming system on biodiversity, and of course, economic assessment, income and outputs. Once all these metrics are measured within your farming system, an integrated approach can show the way towards a more sustainable future. So that's looking at trade-offs at a farm level. At a country level or a global level, we can look at the issues around China's thirst for milk. Milk demand will increase by 60% between 2010 and 2050, with 70% of this in East Asia. So how will China develop enough milk for its growing population and increasing demand for milk? Well, the options are China could import the extra milk, but this becomes a larger burden on the global economy, putting larger pressure on milk-producing nations with little development of the Chinese agricultural industry. But because other countries are more efficient at producing milk currently, it may produce lower emissions. An alternative is that you increase national milk output in China. This will increase the amount of feed as a global resource, importing alfalfa from the States and soybean from South America. This will have higher emissions in China because of a lower efficiency to produce milk, but it will develop the industry within China and increase jobs. The solution resides in a combination of the two. Sustainability of livestock production is extremely challenging. The problems are multidisciplinary and cannot be addressed at a single site. We need to develop a network of model farms where we can start to look at the most efficient way of producing ruminant livestock. The global network of farm platforms was an initiative which was developed to work together with farms across the globe, each with a different element of ruminant production, from landless farms in India and Africa, nomadic farms in Africa, dryland farms in Australia, range beef systems in the US of A and in Canada, and intensive productions in China and the UK and other parts of Europe. Through all these systems and collectively we can learn from each other, so we can develop the most sustainable way of producing livestock and the vital part and the position of livestock products as part of food security.